Thanks for joining. So let's start quickly with the introduction of data engineering. So today we'll go over what exactly the data engineering. Okay. So what are the various things are associated with the data engineering? Why data engineering become famous? Okay. So what are the various technologies within the Azure when it comes to data engineering, and what type of demos we will be having during the sessions, okay, and why there are more jobs in the data engineering, and what technologies are, what are the things that you need to learn to get into data engineering job, right? So these are all the things we will start learning, okay. So before that, let me start about myself. So let me introduce myself. So I'm PC. You can call me PC, and I have around 16 years of experience in database BI ETL technologies. Okay. And yeah, I have around 16 years of experience in DBBA ETL data engineering with various roles. So developer, dev lead, architect, okay, all the roles I played across during my experience. I started my career with SQL Server developer. Then I worked with Informatica, Oracle. Then at the time the SSIS was becoming famous, just recently introduced. Then I started working with SSIS, SSRS. Then I confined myself to Microsoft technologies. Okay. So from past around 5 years, when the data engineering came into picture the first time, so I was I got interest in that. So I thought this is going to be the future. So I started learning and exploring the things. Then unfortunately, in my company where I used to work, they got some good number of projects in the Azure Data Factory. So then I got the opportunity to work there. So from there onwards, I continued my Azure data engineering journey. So I executed multiple projects end to end, and at the same data engineering, I joined with one of the product-based company in Hyderabad, where I'm working as a dev lead come architect. Yeah, and yeah, so I'm Microsoft certified Azure data engineer. So DP203 exam gives you the data engineering certification for you. So where I have this experience. So DP201, 200, there are two exams during that time. So I cleared those two exams, but now there's only one exam, 203. So my exam is getting, my certification is getting expired very soon. So I'm attempting this exam again in the last week of this month. So whenever you want to renew the exam, either you can write the exam again, but now you don't need to write the exam actually. So they will have some small assessment. If you clear that, then they will renew it. But still, I'm planning to attempt 203 and get it clear. And I'm a Microsoft certified trainer. So I do train the people like online and offline. And even within my company, I train the people. I design the course for the new people who want to get into a data field, right? So these are all the things I do. Uh, Interested in teaching and knowledge sharing? Yes, I'm very passionate about teaching and knowledge sharing because like that gives more relaxation for me away from all these official things. Okay, and yeah, from past like 10 years or so, even during my study, I used to teach MS Office, C++, like at the time. So I continued my teaching journey. In between I gave break, but again I started with SSIS, SSRS. Right? So that's all about myself, and we will have quick introduction of each one of you at the end of the session when you stop recording. All right, thanks. Now let's talk about the cloud. So when you go to data engineering, right, when you actually get into data engineering, first you need to understand what is cloud. Okay, so because data engineering is more aligned with the cloud. Okay, so before getting into the data engineering profile, the database developer, like all those things, how data engineering evolved. Okay, so we must understand the basic of cloud, the basic definition of the cloud. Okay, I'm going to introduce the cloud definition very quickly. I'm not going deep because it's just initial session. Very soon, like when we start the actual sessions, then I will go with the cloud definition. Okay, not to worry about it. Let's quickly start now. So what is the cloud? So cloud is nothing but delivery of computing services over the internet. So before cloud, so when the cloud was not there, initially, what we used to work on? We used to work on the on-premises environment. So everybody knows what is on-premise environment? Does everybody knows what is on-premise environment? Are you able to hear me?
Yes, yes.
So what is on-premise environment? When somebody says on-premise environment, what is that?
It's like nothing but a server, storage, everything is in one place.
Okay, right. So what?
Cell phone.
Yeah. So you need to
Infrastructure is everything is in one place.
Right. So cloud is also same thing, but the only difference would be the infrastructure, whatever you're talking about, the infrastructure, everything will be one place, but that will be managed by the people. Okay, that will be managed by the individuals like we or you. Okay, whoever works for the organization, they maintains that. Okay, that is also called private cloud, private data center. Okay, these are all kind of on-premises environment where individual takes care of everything. Right? Say suppose I have an application, okay, which I am planning to develop very soon. Okay, and there is a product I am planning to set up a company. So what I will do, I will go for a physical place. Okay, suppose a building or some corporate office, some building I will hire. Right, I will rent it out. I will take for rent, and I will set up the servers, the computers, right? Then the software, hardware, everything I will be taking care of that. Right, so I will install the software. I will arrange the hardware, like the machines, the CPUs. Okay, and also I need to take care of the operating system, the SQL server. If it's SQL server, then the front end, back end, all the operations I need to take care, then proceed further. Right, so this is itself takes some good amount of the cost and effort for setting up this. Once it is done, so what I need to do, I'll start creating the application, the product. Okay, suppose it's e-commerce application, then I start working on that. Once the development is done, I will build it, I will deploy it, then I will start managing the application at a continuous intervals. Okay, that's how on-premise environment works, the private cloud works. Right, so but on-premise environment will have some issues, the basic issues. Right, say suppose the building where you have that your organization or your setup, all the setup, so suddenly got some power fluctuation. So what happens, your application will be down and your entire system is down. You may not be able to take it, like you may not be able to recover it. Okay, it takes some time to get back the application on track, but by the time if any user is trying to access your application, they will be disappointed. Right, your credibility of your application is gone. Right, in the same way, suppose your computer power, sorry, your hardware or your servers are capable of handling only 1,000 users or 10,000 products. Suddenly the 1,000 users become 2,000 because your company, so your website become very popular and you have added some of the promotions. Okay, so when the user base is becoming more, so what happens, your website gets crashed. Right, that is also one of the issue. So to overcome the issue, what you can do, you might need to add some of the servers, and so that there won't be any issue of the crash or something. Right, but after a while, suppose the 2,000 become 1,000 again. Okay, so 10,000 become 1,000 again, or the number of users back to the original. What happens, whatever the additional servers they have to added, that is become waste. Okay, that becomes waste. So your all the money you paid, that is going to be wasted. Right, this is the issue. Right, and networking. So networking in the sense, so whatever the software, sorry, what is the front end and software you are trying to connect. Okay, so there is an issue, there might be an issue in the networking, or how do you expose to the outside world with the security that might be the issue in the on-premise environment. Or suppose some natural disaster happened. Say suppose your what do you call some tsunami or earthquake happened. Then happens your entire system is gone, your data is gone. You may not be able to even recover it as well. Okay, that is also one of the problems. So human issues are natural disasters. These are all kind of issues might affect this one apart from the maintainability. Okay, so you may not be able to manage properly when your application gets more hits and less hits. Your application gets keep on uh, oscillating like up and ups and downs. Sorry, some disturbance in your voice. Is it? What is telling why? Speak out if you feel there is a lag. Right? Okay. So all these are the issues basically from the on-premises environment. Okay. So to overcome that on-premises issues, okay, to overcome that on-premises issue, slowly people started opting for the cloud. The more and more thing came into picture, research came into picture, the cloud came into picture. So what is the cloud then? Whatever the services I was talking about in the on-premises environment, that is computer power, the virtual machine, front end, back end, the networking, all these are will be provided by the over the internet. Okay, all these services will be provided over the internet to the individuals so that we can start using that infrastructure and start working on our application. Right? That is the cloud. The same thing, whatever you do in the on-premise environment, the same set of things will be provided, but they will be provided over the internet. There will be somewhere some place like a single place from where you will try to access all those services over the internet. There is nothing but the cloud. Right? So delivery of computing services over the internet is the cloud. So the services can be a storage, a computer power, networking, and analytics. Analytics in the sense how your resources are performing, how your application is performing, how your servers are performing. Are there any ups and downs? Okay. Are there any what do you say threshold is crossing in the database server? Okay. So all these things can be managed with the analytics. Okay. So what are the services? These are listed down. So these are all will be provided over the internet by the cloud. Right? Now, if you talk about the provider, so we have three providers. So one is the Azure. So Microsoft is a cloud provider for that. Microsoft is a provider, and AWS, Amazon Web Services. Amazon is a cloud provider. GCP, Google Cloud Platform. So major, we have three cloud providers who provides the set of infrastructure to the individuals and technologies. Right? So as AWS is a leading, Azure is the second, GCP is the third, but the difference between Azure and ACP is, sorry, AWS is getting reduced, and very soon Azure is going to top in the list in the market share. I'm sure about it, because like if you compare every year percentage of share, okay, the market share every year, the growth from the previous years, Azure is continuously performing well. It's more than 40% of the growth is compared to previous years, but whereas AWS is lesser than that. So very soon it's going to capture, the Azure is going to capture the entire market, right? So that is about the cloud. Now let us talk about the data engineering. Now we need to also talk about data. Now we spoke about the what is cloud and all. Now let's talk about the data engineering. So before jumping into data engineering, we need to understand what are the various roles that were there earlier before the data engineering started evolve. Okay, because data engineering is kind of a latest terminology which which age is like not even a decade, right? It got introduced very recently, right? Now when the software started initially, like some decades back, okay, so what happened? There used to be front end, back end. Okay, say suppose I'm developing an application, so it will have a front end, it will have a back end. So suppose a bank application is there, so bank will have the interface, and the back end will have some database where you store all the data. That is the front end and back end. Right? Now say suppose we want to design the database, we want to run procedures to manage the data, all these things you want to manage. So who will do that? Database developer does that. So database developer was kind of the first role in the data world. Okay, so who used to work on all this database development? Database development can be like procedures, functions, some SQL code, right? And designing the database, creating the tables, all these things would be done by the database developer. Okay, so at the time that was the rule, right? And the backend database is called what? Transactional database. So you have the transactional database. The transactional database will be used to store the data. Suppose you have okay, this is the front end. This is the backend. Okay, this is a database. This is a web. Okay, so what are the transactions? Suppose if you have the bank, so the bank will have credits, debits, customers, loans, and all. So as soon as you perform all these transactions, the user, so the transactions keep on storing in the transaction. This is also called transactional database. It's also called operational database. Transactional database, operational database, backend database. Okay, so these are all get stored over here, right? So at the end of the day or the end of the month or end of the year, say suppose bank want to analyze the things and take a decision based on the its performance. So what they will do, they will fire some queries. Suppose this is a user, this is a top management guy. Okay, he will fire some queries on this database, okay, and get the reports out of it. Okay, then he will analyze those reports and see how your bank is performing, how many loans got, how many lockers got, how much deposits we got, okay, how much of bank loans we got, which city is getting more customers, okay, within the city. If Hyderabad is a city, in Hyderabad which location need ATMs, okay, which location got so much of deposits. Okay, these are all things they need to analyze, right? Based on that, they will take further decisions on their bank expansion or the improvising their what is it, the facilities and all, right? That's how this management, the transaction database works. But over the period of time, what happens? This database gets increased. Okay, initially it might be MBs, it will be GBs, TBs, and all. So it goes on increasing over the period of time. When this data gets increased over the period of time, there is a big challenge to fire the queries on the same database, because you are executing the queries on the same database for reporting, and you're inserting or updating the data for the same database. So what happens? There'll be a performance hit because you are kind of giving stress to the database by performing multiple operations, right? And also you need to perform aggregations and all, which also takes some of the time to get the reports, right? So to avoid the problem, slowly people thought they should have a separate database for the reporting for the top management to analyze. Okay, then the concept of data warehouse came into picture. Okay, then the concept of data warehouse came into picture. So the data warehouse, what the data warehouse does? The data warehouse does it stores the data from the transactional database on the regular basis. Say suppose for every day, at the end of the day, I will load the data into data warehouse. Okay, or end of the month or weekly ones, based on the management or based on the user requirement. So day-to-day basis, at regular intervals, all the transactional data will be storing in the data warehouse. From there, now instead of generating the reports from the transactional database, now the user gets the reports from the data warehouse. Okay, so that there won't be any burden, there won't be extra burden on this database. Okay, the overall reporting responsibilities lies on the shoulder of data warehouse, right? Now there is no disturbance. So this database, there is no disturbance to database. Okay, so it will keep on performing its operation. Transaction database, it will keep on performing its operation. The top management, the results, that reporting purpose, right? So this data warehouse is being designed. Now when the data warehousing started evolving, the construction of data warehouse is required. That's where data warehouse developer came into picture. Earlier only database developer, now database developer are kind of an ETL developer who gets the data and loads it into here. DWH is called ETL developer. So if you remember, like 1 or 2 decades back, like 20, 15, 16, 17 years back, or 20 years back, there was a concept of data warehouse developer or ETL developer became very famous because of these reasons, because data warehousing become very booming technology at that time. Okay, now also of course. So now there is a separate database which is being designed and maintained by the ETL developer. Now earlier only there was a role of database developer, now the role of data warehouse developer and ETL developer came into picture. Right? So far, are we good? Are understanding what I'm trying to explain here? Is everyone able to hear me and trying to understand? Is there
Yes,
any
yes.
confusion? Okay, is it
Yes,
clear?
yes, yes,
Okay.
clear.
Yeah. So feel free to push me back.
Hello.
If you yeah.
Can you please repeat once again regarding the transition database and data warehousing? What is the difference that I have missed the point?
Sure. So anyway, we have separate session for this, but let me quickly go through that. So transactional database is the one which maintains day-to-day transactions. Say suppose you are going to bank. Okay, you are opening account, then the data will be stored in the transaction database. Suppose you are create some amount, you are debiting some amount, you are going to ATM and depositing or withdrawing some money. Okay, you are swiping your credit card or you are performing some online transaction Amazon with your credit card. So all those things will be stored in the transactional database, backend database. Suppose you are going to a bank, a supermarket. Okay, you are purchasing something, then the invoice will be generated with your customer details and as well as the goods or the groceries, whatever you purchased. So those all will be stored in the transaction database. Suppose you are going to hospital. Okay, then your patient name, details, your consultant doctor, right? So what is your issues, right? What are the medicines? What is the fee? What are the tests that you're undergoing? All those will be stored in the backend database for that application, right? So day-to-day transactions, whatever you are performing, those will be stored in the transactional database. It's also called operational database. Every application will have an operational database. That's a transactional database, right? Now, after the going to the data, say suppose the same hospital, I'm giving an example apart from bank. So the top management want to see, suppose Yashoda hospital want to see today how many patients got admitted. Okay, how much revenue, how much money we got. Okay, how many heart surgeries we perform, how many knee replacement surgeries we perform. Okay, at regular basis they want to perform like monthly wise, weekly wise or daily wise report they want to generate. They will use the same transactional database for the analysis. But at the end of the day, if you are using the same database for the reporting as well as the transaction, then the performance this database will be down. So there will be issue whenever you are performing the transaction. There will be issue whenever you are performing the reporting. Okay, so that is the reason what they did. They separated out the database exclusively for the reporting. They designed something called data warehouse. So data warehouse will have the data from the transaction database, but it's an aggregation. It will have so much of database. Like say suppose it has like 100 tables and all, but I need only some data out of it because for the reporting purpose I don't need all the data. Apart from that, I don't need any the individual data. Suppose you are performing suppose 1,000 customers came into supermarket. 1,000 will have 1,000 invoices and each invoice allowed 10 products. It will be 10,000 products, the total invoices. But when it comes to data warehouse, we don't add all the data as it is. We aggregate it. Aggregate in the sense at the end of the day, how much money got collected, which brands got sold, which products got sold. We aggregate it, we summarize it, then we store the data into data warehouse so that the management or the end user quickly generates reports after it and evaluate the company performance. Right? So that's where the data warehouse came into picture. And constructing the data warehouse from the database is the responsibility of the ETL developer or data warehouse developer, which was earlier the roles used to be. Right? So there is a difference between the transaction database and data warehouse. Anyway, we have separate session for explain this and deep dive into this. We'll discuss more on that at the time. Right? Now, so these are all used to happen. Now, when the internet revolution happened, now more and more technologies came into picture. Then when the more and more technologies came into picture, the data has been increased tremendously. It's all become terabytes and or more than that. Right? Now the data has increased a lot and company also started thinking that apart from analyzing the current data and take a business decision, we should also analyze the current data and take a and analysis or predict about the future. You need to predict the future, how the future is going to be. Say suppose Yashoda Hospital. So if more and more heart surgeries are happening, and more pollution is increasing, more and more stress is increasing, they might think that okay, in the next 10 years, there will be more number of heart diseases, there are more number of knee disease, there are more number of overweight issues. So according to that, they need to plan their doctor recruitment, they need to plan their budget, they need to plan about their branches and all. Okay, so predicting the future based on analyzing the current data is about the data science, right? Now, whenever they want to predict the data, but they need the data to be analyzed. But the data, if you take any hospital, if you take any application, there are multiple databases. Say suppose I'm taking Azure Hospital, some data might be in Oracle, some data might be in SQL Server, some data might be in web application, some data might be in flat files, right? The data might spread across multiple ways, but they need to get the data and give it to the data scientist to perform analysis, right? But when the data and scientists want to perform the analysis, you want some good data in aggregated data, right? Because the data is spread across multiple places. 1 second, let me clear this off. So the data is, suppose they have multiple sources, multiple formats. Okay, it has format 1, say suppose this is the structure data, the JSON data, CSV data, right? Table data, web data, like XML data, all this data is there, and different sources, source 1, source 2, source 3, and the data is also huge. Whenever there is data is a huge, the data is spread across multiple sources, multiple formats, that is called big data. Okay, what is big data? The data which is spread across multiple sources, multiple formats, and at the same time the data amount of the data is huge, that is called the big data, right? So if you take any organization, they have huge amount of data, but they want to give to the data scientist to analyze it further. So what they will do, they will get the data into a common place, okay, in a common format. Suppose all format 1, format 2, format 3. I'll take a simple format called final format and into a common target. Okay, so that the data scientist can analyze the data, or reporting developer can generate the report. Reporting developer means business analyst can generate the reports. Okay, for these things, for this kind of things, we need a data engineer, because the data scientists need a clean data, same data, but the data is spread across multiple formats, multiple things. Now data engineer gets the data from all these sources and give in a common format, and get the data to common format and store it in a single place, so that data scientists can consume the data directly and perform its analysis, right? So these are the data engineers. So the professionals who build pipelines to transform the data into the formats that readable and usable for the data scientists. The pipeline is nothing but taking data from discrete, that means different sources, and storing them in a single warehouse in a single format. That's what the data engineer does. So it's kind of a, if you take any reporting project, if you take a data science project, so data engineer is kind of a backbone of the project, because he is the one who is getting the data, transforming the data, and loading the data to give it to the end user. The end user can be a business analyst or data scientist. And this extracting the data, loading, transferring, all these operations are there, right? So this operation, this set of operations is called pipeline. Okay, it's called pipeline. So pipeline is nothing but getting the data, performing transactions, or storing the data, like, and to make all these transformations end to end is called pipeline. So this pipeline will be developed by the data engineer, right? Now earlier there's the database developer, then the data warehouse developer, then the ETL developer, business analyst. Now latest is data engineer, right? So that's what the data engineer does. Everybody is clear what exactly data engineer does?
Yes.
Okay, people are not speaking out. Must have been sleeping mode.
Yeah,
Okay.
yeah, it's clear. But one thing is, who is the data scientist here? It is from business side, or there are some another consultant sits on top of us.
Yeah, there will be some other concepts. If you take any data science project, there will be set of data scientists and set of data engineers. So once you get the data in data engineer, the data scientist comes into picture, then they will start predicting or creating the model sort of it. There are also like consultants like us.
Okay, not from the business side, right?
Not from the business side, no.
Okay.
Okay. Now let's go back to the difference between the data scientist and data engineer. So if you want to take a higher level, data scientists create hypothesis, test, analyze, and translate using clean data. But whereas data engineer design, build, and arrange the data to be clean. So data scientists need a clean data to create hypothesis, but the data engineer is the one who is going to provide that clean data. So data engineer is kind of a backbone of this entire project. Okay, without him, there is no data science project or reporting project. Now you got the major how important the data engineer in any project, right? Now when it comes to data engineering, sorry, data science, data engineering evolve. So now data engineering dimensions has increased. Earlier they used to support data scientists. Now even though even you're working on data warehouse project in the cloud, okay, those are also called data engineer. So that is the reason you don't see the roles like ETL developer or data warehousing developer nowadays. Everyone is a data engineer now. Whoever deals with the data, whoever gets the data, whoever deals with the data, whoever works with the latest cloud data technology, they're all are data engineers, right? So that is the reason you see more and more job opportunities in the data market. Now let us
Yeah, Purushottam, I have one doubt here. So if we can able to have entire control on the data as a data engineer, why
right.
can't we convert as a data scientist? Like what stops us to become a data scientist as well? Like what are all the
Right.
things we are going to
Yeah.
be
Yeah.
take care for data scientist?
Yes, data scientists need extra things, like you need to have more. If you see the skill set here, you need to be more better in the maths and statistics. You should know MLA models. You should be more thinking of advanced analytics side. Okay, you should have more of a statistical mathematical ability, and you should be able to build ML and AI models. Okay, those things I have. So unfortunately I don't have myself. Okay, so I don't want to become a data scientist. I don't think I have that level of skills. Okay, so it all depends upon the person to person. If the person is a data engineer, extends his ability to learn these things, yes, definitely he can become a data scientist as well. He can play the role of data scientist as well.
Okay, clear. Yeah.
Yes. Now let's talk about the old slide, which I need to change. But here at the high level, if you talk about any data engineering project or any data engineering, whether it's the AWS or GCP or anything, there'll be high level, there'll be 4 phases of the data engineering, 4 different phases: ingest, store, prepare and train, model and serve. These are the 4 things which you have. Ingest in the sense, ingesting the data, extracting the data directly. Okay, because the data sources are multiple places, multiple formats and all. Extracting the data is a key challenge, a big challenge. Now we will get the data and we will store the data temporarily at some place. Okay, we'll store the data temporarily at some place. 1 second. Yeah, so here extracting the data is a first challenge, because that is the biggest challenge I can say, because the data is spread across multiple sources, multiple formats, and connecting to that external source is the biggest challenge. That's what ingestion phase does. Ingestion phase is the one where we connect it to sources and extract the data, is the ingestion phase. In this example, I'm using Azure Data Factory technology to ingest the data, right? Once you ingest, you temporarily store it somewhere. Okay, you temporarily store it somewhere. This is a store phase. So in this example, I'm using the Azure Data Lake storage to store the data, right? So once you store the data, you need to convert the data so that the final people, the final users will consume the data. Okay, so according to their requirement, we will convert the data. That's called prepare and train. In this example, I'm using the Azure Databricks to convert the data. So once it is done, we need to model it and store it in a data warehouse or any other place. So here I'm using the data warehouse and as well as the Cosmos DB to store the data for the end user. Okay, so once this data is gets stored over here, then the further the reporting guy or the data scientist will consume this data. Data scientist or business analyst, that is also called reporting developer, will consume the data. That is called model and serve, modeling the data in the data warehouse. Now this is example, we are using Azure data SQL data warehouse. Now the latest name of this is dedicated SQL pool in the Synapse. This is called dedicated SQL pool, right? So these are the things which are highly high level terminologies when it comes to data engineering. Ingest, store, prepare and train, model and solve. These are the 4 things which you have, right? Now, irrespective of any project, irrespective of any cloud, these are the 4 essential things. The only thing keeps changing is the technologies. The technology might vary. If we talk about same Azure data, we will have Azure Data Factory. If AWS, that might be some different technology. Even within the Azure also, if you have some amount of the data, I might use Azure Data Factory for the batch data. If there is a streaming data, I might use Stream Analytics. Here, sometimes I might need to use Azure Data Lake storage. Sometimes the people might need to store the data directly into the database. Okay, these are all keeps on changing. It all depends how you want to analyze data, how you want to design your system. Okay, so these are the 4 important bases which you must understand for the data engineering.
Yeah, here in which area we have to write a code to transform the data from one form of suppose say unstructured to structured, right?
Yeah.
So where we can implement our code, like in this out of 4 things.
Yeah. So here, if you see this entire project end to end, so finally given to data and scientists or business analysts, see here, almost 70% of the role is being done by the data engineer. Okay, which is very critical. That's the reason, as I was keep on saying, is the backbone of any data project, data engineer. Now, where you transform the data, once you store the data, where do you transform? The transformation comes into picture into prepare and train model. This is where you transform the data from end to end. Okay, so sometimes you transform the data in the data lake from zone to zone also, but here is the one actually when you transform the data, and here you might write some code, or you might use data factory, you might use some procedures. It all depends upon the the case to case basis. All right,
based on the requirement, right? So
based on the requirement, based on the budget, based on the technology which you have, all those comes into picture.
Okay, so what are all the prerequisites here? So do we need a Python, Scala, or any other?
That's what I'm saying. It all depends upon the various scenarios. So if the data is huge, data is vast, data is a huge, but still the client does not have enough budget, the client has less budget, the client says that I'm not concerned of the timelines, but still I don't want to use more cost, right? So these are all things comes into picture. Based on the requirement and all, we'll design different kind of technologies.
But what is the most effective way? Like
usually when you transform the data, usually most of the people uses the Databricks currently. They use the Databricks for the transformation, ingestion uses the Databricks. But some projects, when there is a less amount of data, less amount of transformation, they are using even the data factory data flow as well. Even I've seen most of the projects who are transforming the data using pure SQL. They are not even using Databricks. I know, like within my company itself, I know multiple projects who are not using Databricks. They are converting the data using the SQL code only. Okay, there is concept called serverless SQL pool in the Synapse. So they use that to convert the data. So it all depends. How do you want to achieve based on the budget, based on the data volume, based on the customer requirement. Okay, it's not mandatory that everybody uses Databricks for converting data. It's not mandatory that everybody uses a dedicated SQL pool to design the data warehouse. It's not mandatory that everybody store the data in the data lake storage in the first place. It all depends upon the case-to-case basis.
Okay, it can be decided by the manager of a project,
architect, developers, all those things. Yeah, you're right.
Yeah, PC, this is Krishna.
Yeah, hi Krishna. Please tell me.
Actually, I'm not in. I just worked as a BI developer, like Power BI, Cognos developer. I did not work as a ETL developer as well.
Great.
So I'm not very much familiar about ETL concepts and all.
Right. Right.
So I don't know much SQL as well.
Yes.
So how I fits in this job?
I will talk about it. Anybody can fit into data engineering, even though I see the people, even testing people. Honestly, I'm saying even the testing people who shifted from testing background into data engineering and they became very successful. Within my project, I have a couple of people who are from testing background. Anybody can get into data engineering. I have separate
How
slide for
come,
that.
like, as per your explanation, most of the part will
Mhm.
require SQL knowledge and
Mhm.
ETL knowledge should require.
No, you don't need
So
to be ETL. You don't need to be expert in the ETL. You need to know ETL terminologies. You need to know ETL basics. Okay, that should be good enough. And of course, if you talk about any programming, any ETL or anything, end of the day, you're going to create same pipeline, same thing, right? So it doesn't matter. Okay.
that's
So
the
we'll
only worry. I'm not able to justify myself, like
no.
how I'll fits in this
I
job.
have separate slide for that. Let me discuss.
Yeah,
that.
yeah.
Okay. Now that is about the data engineering. And in the data engineering, if you talk about a nutshell, it's application of business intelligence on the big data. We analyze it, we ingest it, okay, we process it, we store it, and we finally give the access to the people, right? So data engineering manages all these different kind of phases. It's more of big data. You analyze the source data, you ingest it, you process it, you store it. Finally, you give the access on the right data to the right people for the right access, right? These are all about the data engineering, right? So we spoke about so much things. Then the what needs to you sorry, what are things you need to learn to become like a data engineer? Okay, how can you become a data engineer? So these are the skill set I listed down, not to join this course. I mean to say, sorry, these are the prerequisite, not for the course. These are prerequisites to become a data engineer. Okay, there's a difference. So if you want to become a good data engineer, you should know the SQL basics. Okay, so in the modern world, okay, in the modern data world, even though you are going for a data or not data, non-data projects, okay, people expect you to be good in SQL. Okay, so you don't need to be mastered in SQL, but you should know at least the basic skills of the SQL, like DDL commands, creating the tables, okay, updating the tables, and performing DML operations, select queries, joins, sub queries. Okay, so these are all the things you should be good, okay, to get into SQL. So if you start exploring the SQL in parallel to this course, then you will be in a comfortable position by the end of the course. You don't need to be master. You should know some of the basic things. That should be good enough. And data modeling text. So data spread across multiple formats, multiple sources. So you should be able to model it in a neat way, because as per the end user, as per the thing, so you should design your database. So that is the reason you should know some of the data modeling techniques. And ETL BI basics, it's more of an extension of ETL BI. So you should know some of the ETL BI basics. So which we are going to cover in the next 2 sessions, the ETL and BI basics. We're exclusively 2 sessions to get to know the things. And architecture projections. So in the previous slide explained, so there will be so many tools, so many libraries, so many platforms. It's the architect and team who decides which tool needs to be used when, right? What all tools you need to use, which tool you need to use. So these are all the things these are all things you need to learn. So when you will decide that, when you will get that idea, when you know each and every tool, its architecture, its usage, okay, when you know all these things, it's very easy for you to project, right? So there's article ability to connect the dots from source to destination. That means, so you have sources, you have targets, so you should be able to connect the dots. That means you should be able to analyze and check how you can get the data into suitable requirement as per the end user pool. Okay, so you should have some good analytics. Cloud, so you should be able to, you should know at least one cloud here. So the cloud can be anything. In this case, Azure base. If you know Azure base, that should be good enough. And we have 2 sessions, 2 to 3 sessions exclusively for Azure and cloud basics as well. And Python, yeah. So learning Python is not mandatory, but it's good to know the Python, because if you talk about the Databricks, you will be using PySpark language, which depends upon the Python. So it's good to know the Python. And during our course, we have 2 exclusive sessions for the Python as well. Okay, 2 sessions I'm going to take for Python before starting Databricks. Okay, so these are the skill set which you need to learn to get into data engineering job. So if you list down all the things, it's all very easy. And data modeling technique, immediately you don't need to learn, that comes with the experience. But rest of things is very easy, and these are all can be covered during the course. Does it make sense?
Yes, PC.
Right? Okay.
Hello.
Hello.
Yes, please tell me.
Hi, Sambhaji here.
Yeah, hi, Sambhaji.
Yeah, Azure Data Factory, which is used to just extract the data and store somewhere, or we do some transformation over there.
That's what I'm saying. So there will be multiple things. So in this example, the previous example, whatever I explained, I extracted the data, right? And some people even they use the same for the prepare and train also, using the using that internal technology, internal feature. Even they use the data flow. Using the data flow, even they can convert the data also. Okay, it all depends. Again, I said, so extracting the data, modeling data, even orchestration, you do all these kind of things end to end. Now you need to group it at a single place, everything. Then also you will use the data factory for orchestration.
Okay.
Group.
And all those things will be covered in this.
Yes, absolutely.
Okay.
Absolutely. Okay, now we spoke about data engineering skills, what needs to be done, what is data engineering, now what is data engineering definition and all. Now we will see what is the demand of data engineering. If you see the recent survey, say more than 50 to 60% of the opportunities are in the data engineering only, because every project is getting into data engineering. If you talk about, suppose an organization, a company freshly going to implement a data science project, then you need a data engineer. Organization, first time they are going to build a data warehouse, so here also they need data engineer. Organization already have some big data project, legacy big data project. Now they want to get on-premise this legacy big data project, they want to migrate to Azure data, then also you need data warehouse, data engineer. Okay, migration, big data migration. Suppose you have all the legacy ETL projects like Informatica, SSIS and all, and you want to convert into Azure data, then also you need a Azure data engineer. And your all existing data logic is in the tail end, the Informatica and all, you want to convert into Azure data vault, then also you need data engineer. See, so there are several cases which needs a data engineer. Now, if you see this, the list which I listed down, there are more and more projects are coming in that line. Okay, more and more projects. Okay, trust me. So that is the reason there is a good demand, high demand for the data engineers in the job market. Okay, that's the reason you see wherever you see you see only data engineer, LinkedIn, Naukri, anywhere. Right? So even within the India, even outside of India, there is tremendous growth, tremendous opportunities for the data engineer. Now, who can start and who can become a data engineer? I told so many things. I spoke about data engineering phases and what are skill set you needed. So many things I spoke about. I also need to explain you who can become a data engineer. Somebody has a question in between for the same point. So DB developer, if you're a DB developer, it's very easy to shift. And it is very good to shift into data because you need to upgrade yourself. You cannot just stick to database developer. And also you already know some of the database basics. So it's easy for you to get into data engineering. Right? Now, BI ETL developer. Already, suppose you have a BI developer or ETL developer, you are good with your ETL basics and all. So for you also, it's very easy to shift, and it is important shift. Not only easy, it is important to shift into data engineering. DBS, so DBS handles the data day-to-day basis, and as the cloud increasing its features, the DBA role is getting minimized every day, day by day, right? So that is the reason it's good to extend their capability into the data engineering. Big data developer. So if you are a big data developer, legacy Spark, Airflow, and all those things you are working, and all those projects are getting shifted to Azure data or any data engineering, it's very good to get into data engineering, and also easy for you people to shift into data engineering, data analyst. Already you are a reporting developer, a Tableau reporter, Power BI developer. Already you know the database basics and data query basics, and a little knowledge of ETL and BI. You can get into easily into data engineering. And data analyst, the combination of reporting plus data engineering is a good in demand in the market. Application developer, if you're .NET developer or a Java developer in any application or Python developer application programming, it's easy for you to get into job data engineering. Also, it is one of the highly demand combination because people sometimes expect not expect, they need good programming people also to write good amount of code if it's there in a department. Fresher, yes, freshers also. If you don't have anything, if you don't know anything, you're just starting your career into IT, it's easy to get into data engineering. I see so many people who are into freshers, but they with a little knowledge of data engineering, people still acquire, organizations still recruit those people. Okay, apart from the testing people also, I see, you know, the testing products are getting reduced lot and lot every day by day because everything is a like integrated to single place. So that is the reason even for testing people also is a very good thing to get into data engineering, right? These are all people can get into data engineering. Now coming to certification, we have DP20 certification, which gives Azure certified data engineer, where the data skill set will be measured in the data storage, processing, security, data processing. So once you join the course, once you at the end of the course, at least you'll be covering 40 to 50% of the actual content which needs to be which you can attempt in the exam. With a little extension of your knowledge, little preparation, you can easily crack 203 exam answer. And we can become a data Azure certified data engineer. It's not mandatory to become to get a certification, but definitely it adds a weightage to your profile, right? So that's all about the and the technologies. Then what are the technologies which we are going to cover? What are the data engineering technologies, Azure data engineering technologies at high level? We have Azure storage account, the first technology, which comes with the what do you say, blob and ADLS. We have Azure SQL, the SQL within the Azure. Azure Data Factory is the integration orchestration tool. Azure Synapse Analytics, I'll talk about it. Azure Databricks, which is a kind of a transformation tool, and big data analytics tool. Okay, so these are all the things which are part of data engineering too, and we are going to handle all this content during our session. And Azure Synapse Analytics, within the Azure Synapse Analytics, so this recently introduced this technology. It is a complete suite for data engineering, where at a single place, end-to-end of data engineering operations can be performed. So here we have SQL pools, we have Spark pool. Okay, we have something called pipelines. So these are all part of the Synapse Analytics, and we are going to cover all these things in detail. Okay, Spark pool, SQL pool, and also we have HTAP, hybrid transaction, analytic processing. All these things will be covered in the Synapse Analytics. Right? So these are the technologies you need to understand to get into job. Okay, so this is all about the introduction, the session, and all. So any doubts now? And yeah, apart, so these are all going to cover. And for all these things, there will be theory session, there will be practical session, series of demo sessions. Okay. Now, before going for Q&A session, let me quickly go into this one. 1 second. There is the excuse me.
Yeah, PC, I have doubt.
1 second. Let me quickly go through this, then we will open for Q&A. Yeah, so these are the data engineering, this one I need to refine further actually. So these are all things we are going to cover: ETL engineering basics, Azure basics, and the technologies whichever I stated earlier. Azure SQL in this, the overview, pricing tier, single database, elastic pool, what is the data factory, what is the control flow, what is the data flow, how to configure it, what is Synapse Analytics, what is the SQL pool, Databricks. So these are all we're going to cover. And for all these things, I listed down the series of hands-on which we are going to do during the training. There will be more emphasis on each and every scenario. So for every technology, there will be 3 sessions followed by good amount of lab sessions based on the what is real-time scenarios and also simple scenarios, right? So these are all about, and I'm also, apart from this, I'm also going to add Azure Purview also, which I will be taking couple of sessions for Azure Purview. And so far, whatever the batches I covered, I never taught a Python, but from this batch, I'm planning to start even the Python session. 2 sessions I'll be taking to make you comfortable with the PySpark. Yeah. Now it's open for Q&A session. You can ask any question, any doubts, any questions regarding the course.
One question here. So I'm completely a .NET developer. So can I completely change it to data engineer, like leaving .NET and moving to data engineer?
Absolutely, you can do, and a combination of a .NET and Azure data is very good choice. Actually, honestly, I'm saying I encouraged so many of my friends to do that. Actually, 1 second, Ganesh, can you stop recording?
Yeah, sure.